Hey everyone, now that we've learned how to integrate products of sines and cosines, let's do a couple of examples. Remember that there are two types of approaches that we use. One approach is u-substitution when one of the powers of sine or cosine is odd. The other case is when all the powers of sine and cosine are even, when we use half-angle formulas, and possibly other stuff. Let's take a look at number one. Now here, we're going to be using u-sub. Remember that we get to save a copy of the odd-powered function. Since they're both odd-powered, we get to make a choice. And since the copy that we save is going to be a du, and I prefer not to use negative signs, let's save a copy of cosine. Now, just to be clear, you can save a copy of sine. It's totally fine, you'll get the right answer. You just have to worry about a negative with the du. So we're going to save a copy of the cosine, right? So that becomes cosine to the fourth, just to be clear. There's my extra copy of cosine. Right, just like that. And remember, this is going to serve as our du. Okay? Remember, the fundamental identity that we use for this is we have to use sine squared plus cosine squared equals 1. Now remember that if cosine is our du, then that means sine is going to be our u. So we want to transform all of our cosines into sines. So instead of writing cosine to the fourth of x, we can write cosine squared squared. Or we could write that as 1 minus sine squared of x, quantity squared, right? Because that's another way to write cosine squared, is 1 minus sine squared. Keeping the sine to the fifth the same. We're looking pretty good right here. Now, you can FOIL this all out if you want. I recommend making the substitution first. There's just a lot less writing, a lot fewer symbols to worry about. So here in parentheses, I'm going to write let u equal sine of x. So du equals cosine of x dx. All right, and now that's going to give us the integral of 1 minus, just to emphasize, u squared squared times u to the fifth du. Right, again, here's our du, just to emphasize. That all went right there. Okay. See how we don't have to worry about that negative because cosine is the derivative of sine? Very nice. Now, let's go ahead and multiply through. Oh boy, we're running into a little bit of space problems here, but I think we can make it work. Let me get a little creative, right? This is going to be 1 minus 2u squared plus u to the fourth, all times u to the fifth du. This is going to give us the integral of u to the fifth minus 2 u to the, seventh, plus u to the ninth du. All right, let's try to finish it off over here. We're going to get 1/6 u to the sixth minus 2/7 u to the seventh plus 1/10 u to the 10th plus c. Whoop, that's a c plus c. Right, and then, of course, when we write that all out, that's going to be 1/6, what is that? Sine to the sixth of x minus 2/7, sine to the seventh of x plus 1/10 sine to the 10th of x plus c. Let's just sort of put that guy off to the side right there. All right. Next up, number 2. Now, hopefully you can look at number 2 and notice, hey, wait a minute, all the powers are even. We're going to be using some half-angle formulas. Now, it's okay that it's only sine to the fourth. It's totally fine. Still, it's even. We're going to be using half-angle formulas. Now, just to note, it's probably better if we start off by writing it like this. Sine squared of x, quantity squared, right? Because we don't we don't know any identities for powers of sine that aren't 2, right? So we want to write it as, squared and then squared. All right, so what we're going to do right now is then rewrite this using the half angle formula, right? This is the integral of 1/2 times 1 minus, careful about that minus sign, cosine of 2x squared dx, right? Make sure to square that 1/2 too, right? Now, when we square that 1/2, we're going to get 1/4. No reason to keep it inside the integral. I'll pull it right out. We FOIL away, and we're going to get 1 minus 2 cosine of 2x plus cosine squared of 2x. Now, just to point out, the reason that I FOILed this one before making the u substitution is, well, because we're not going to just make a straight-up u substitution in this problem. I guess there's a tiny one right here, right? You could let u equal 2x. I'm going to go ahead and skip it. I think we could probably handle that in our heads. If not, then feel free to write it out. But we're going to wind up with 1/4 x minus 1/4 sine of 2x. Remember, when you let u equal 2x, then du is going to be 2 dx. So that's where that 2 went. Okay, right? Just take the derivative. It should work out. And right, and the 1/4 is coming from this guy, right? Okay, so don't forget about that. Now this integral is a little bit more involved, right? 1/4 times the integral of cosine squared of 2x dx. And you might remember from today how we handle such a problem. First off, we just copy the stuff we had before. We simply use the half angle formula again, right? No reason not to. Double negative. Just be a little careful here. The period doubles, so it goes from 2x to 4x. Please don't forget to double the period. Thank you in advance. All right, let's write out our answer. Thank goodness none of this stuff has bounds, right? It'd be kind of a pain to, plug in the bounds on top of doing all of this. Am I right? So anyway, you plug that in. 1/8 x. Let's see. That's going to be plus, right? It's going to be sine. We do have a u substitution to worry about. I think it's going to be 1/2 sine of 4x plus c, right? Because we took the derivative. No, I did that the wrong way. I think it's going to be 1/32, right? Because you take the derivative, it's going to be 4 cosine of 4x. You're going to multiply 1/32 by 4, and then you're going to get 1/8, which is what we have, right? And just to simplify a little bit further, because we can, note that we really should write this all as 3/8 x, right? I guess we could do that. So equals 3/8 x minus Okay, remember we're combining like terms here and only like terms. There's no way to nicely combine sine of 2x and sine of 4x. I mean, maybe you could try, but no, don't do it. Okay, do not simplify that. Okay, awesome. That's how we do that problem. Didn't leave ourselves a whole lot of room for number 3, so we're gonna just do it and hope for the best. All right. Now here, there's only one trig function, right? Cosine, but it's raised to an odd power, so we do the u substitution trick. So we're gonna write the integral of cosine to the 5th of x dx equals the integral of cosine to the 4th of x. This is not going to work. Let's worried. Let's take that guy right down there. Looking great. Times cosine of x dx. Right? Same thing as before, just save the copy of cosine. So remember, the cosine of x dx is going to serve as our du term, which means we're going to have to get the other cosines to the 4th in terms of sine, right? And we've done this sort of thing before. Hopefully we see that we can write this as 1 minus sine squared of x squared cosine of x dx. And I think this will work out pretty nicely, right? Because here we're going to, at this point, let u equal, once again, sine of x. So du, again, very nicely equals cosine of x dx. No need to worry about a negative sign or anything like that. Shouldn't be drawing arrows here, but this is just notes, right? We're okay. And yeah, just do that, okay? So we're going to equal 1 minus u squared du. And that's going to equal 1 minus 2u squared plus u to the 4th du. Right? That should be legit. I think we're legit. Okay. And then that's going to give us, of course, u minus 2/3 u cubed plus 1/5 u to the 5th plus c. And that's going to equal, right, unsubstituting as we always do, sine of x minus 2/3 sine cubed of x plus 1/5 sine to the 5th of x plus c. Whew. That's how we do those trig integrals.